be heard. Yeah. Okay. Hello. You come for the very different thing tonight. I just joined as well. Chave Troll, are you familiar with proof assistance at all? Need to make that a bit bigger. I can't read anything. Not really. We'll see. I mean, don't feel obliged to stay if it's not very interesting. But if it's interesting to you, don't hesitate to ask questions. I don't, but I do stream because it forces me this sort of things because it forces me to sort of reserve a chunk of time to work. Is it like the Curry-Howard thingy? It is related. It can be related to the Curry-Howard thingy, but doesn't need to. In this case, it will be very mildly related, to be honest. So the job of a proof assistant is to make it terribly hard for you to write proofs. Well, not really, but it tends to be that, despite the name, because the real goal of a proof assistant is to make sure that your proof is 100% correct. So you teach the proof assistant some logical rules, and and with these logical rules, you will have to apply them scrupulously, like much more precisely than in a pen and paper proof, in order for the computer to accept, yes, you have applied correct rules to deduce the result you wanted to prove. And that's the general idea of what a proof assistant is. And then the realization can be vastly different. There are some realization based on sort of old-timey logic, which is more or less where I'm getting today. Well, I'm going to do very little. I think we've got about 3 hours, and I haven't written a line yet. Well, I've written a line, but not much more. One way that is common and that I studied while I was being a researcher, doing my PhD, etc., is completely based on the Curry-Howard isomorphism, whereby you have a very rich programming language and you blur the line between proof of a proposition and a program of a type. It uses a typing technique. Well, it's a family of technique called dependent types. In a dependent type, you can have the type of an expression depend on the value of another. I don't know. A typical example of this is on the stack by iterating, currying over a natural number. It works-ish. And the system we're going to try to build tonight, or start to build tonight, has some dependent types. It can speak about lists of length n, but it will not be able to talk about functions of arity n. It has a more restricted pattern than something like Coq or even Haskell to some degree. It will have more and less than Haskell. Haskell is just our host language to program this thing. So to some degree, we're writing a type checker and a proof checker, or we'll be starting. I think everything's in place. My screen is a bit jumbled, where you see a a web browser here to the, I guess it's the, where is this? The left of the screen is the right of the screen, which is there. Right, it's my left, it's your right. No, it's your left as well. No, I'm confused. No, it's on the right of the screen. Whatever. It's really weird to see oneself not in a mirror. So on the right of the screen, I've got a Nemax buffer that I will try not to use. If I use it, please tell me that I'm using the buffer that is hidden. Yeah, exactly. There's a browser. What? Where am I? I think I'm in the wrong branch. Yeah. Okay. It's weird that that it was not. Okay, so then on top of the browser is GHC ID that will give you the state of my project, errors, warnings, and a test which is currently printing f of 1. So I was going to switch to my main thing. There will be 2 files today, main and refined. The only reason for that is that I can only use, so let me just go to refine. I define here a grammar that defines data types using the BNFC meter package. And that's going to define my abstract syntax tree and a printer and a pretty printer, etc. So that's the current line. Right now, I just have I can write natural numbers and I can write applications. And I can use identifiers, and we'll sort of build up something from there. Okay, and to be able to use the quasi-quota for my expressions, I need to be in different files because of limitations in template Haskell, which, to be fair, is an impossible problem. So it's good enough as it is. So I don't need this anymore, actually. That was in the other file. It didn't rebuild. That's interesting. Oh, yeah, it works. Okay, good. So see, yeah, when if I add an error, you'll see the error on the right. Yeah, we don't see the prompt here. If I pop up a terminal window on a white background, my prompt is completely unreadable on white. But the text will be dark, and that's all that counts. Also, I feel extremely weird not to have my headphones on while I'm having this conversation. Okay. So what is your game plan? The game plan is use refinement. No, that's how it's spelled. Types, but discharge proof obligation manually. That means that I will have some. It will have some things that come from the from refinements, and I'll use a star instead. Oh, that may be a bad idea. Okay, I'm using a plus instead. Okay. So usually when people talk about refinement type systems, they're talking about things like liquid Haskell and everything is automated. I don't want that. Terms have a unique intrinsic. How do you spell this word? Intrinsic. Okay. Type. Which will be a simple type for now. Could be something like f omega in some ideal future. My Emacs is very well configured, so every time I enter a Greek letter, and the vertical spacing becomes huge. It's fantastic. Also, I spelled could in a very interesting way. I'll see later. Terms are assigned refine type, but they can have many like I should say, if it's f omega, it should be something like I can't go there for some reason. Oh yeah, Ella Church f omega. That means that the lambda, the type abstraction is explicit. There should be a unique intrinsic type, and the intrinsic type is really, I guess, really the representation of the type. But they may have but the same term may have many such types. There is an erasure function from refined types to intrinsic type. I still can't write intrinsic. I don't know what I did wrong. Features subtypes will features. Subtypes, quotients, and universal quantification. Existential 2? I don't know. So compared to standard dependent type system, types are more rigid, since every type erases to a single intrinsic type. For instance, we know statically how many arrows a type has. But we don't have to care about proof irrelevance, since proofs are not part of terms, they are really side conditions. Maybe I should say, whenever a term is used, a proof obligation for proof obligations plural, that it satisfies the refined type is has to be proved to talk about the term at all, which I hope we can discharge many of them trivially. Quotients are easy to, and we don't have to care about conversion limitation of a conversion function. We only have to discharge equality proofs. And compared to a system like Nupal, there is a type checking algorithm. We don't have and termination can be proved as a side condition, or termination totality. Usual caveats about hypotheses may apply. Observed future anyway. So what I'm saying is that you can't rely on something being total just because you proved it locally, because you might have proved it with axioms that are not true, or with assumptions that are not true. So if we use computations as proofs, we can't really rely on things being terminating. But it doesn't let us prove untrue things anyway. So that's okay. Yeah, the worst that can happen is that we crash our computer. I guess. For now, I'm just going to assume. For now, we'll just pretend every function is total. The intrinsic type. Oh, I can't write this word. Intrinsic type is really about partial functions, as usual in programming languages. There was another point I wanted to make. What was my other point? I don't know. I'll remember at some point. Another thing, like how I wanted to approach this yet. We're going to go back to the other file. We're going to extend this and start talking about intrinsic types. So I type will be for intrinsic type. It can be the string nat. Actually, yeah. I'm actually going to just use Unicode, otherwise it's going to be annoying. So, and that here. I'm going to call this inat for now, because I'm going to define everything in the same grammar. Okay. Oh, there's another nat here. Yeah, sure. And that will be inat1, and we'll have something of type itype, and oops. So BNFC meta is great, but it's a bit under documented. Yeah, well, it doesn't matter. It's more than I need, but so that will be I arrow, and so we'll just say it's an I type 1, followed by an arrow, followed by an I type. That's all we're going to have now. It's not happy. Why is it not happy? Semicolons. I've had this keyboard for a year, and I still don't know where the semicolon is. Wow. Interesting. 30 reduce conflicts. Does someone remember what reduce conflicts are in LILR? I don't see how it could. Why is that? Let's just be sure that it's not because of this. Oh, it's because that's I type here. Now that is much better. I really wonder what it was trying to type before. So that defined me a type INAT. Now we can just like have a look at it. Okay. No, wait. I don't know where it's done. I'm okay. Slowly, main. Okay, so we can print another expression. So I've got a night type, maybe. I don't know how it's going to be capitalized. And let's parenthesize here. Nice. Okay, it doesn't like Unicode at all. Wow. Isn't that beautiful? Wow. Okay, so it doesn't like Unicode. I don't know why, but we're going to pun this. Well, I can write the code points correctly because Haskell strings are I'm a bit annoyed about that because Unicode is very useful for this sort of things. We're gonna have so much notation. Okay. Wow. So the parser handles Unicode perfectly. It's the printer that doesn't, apparently. I'll investigate that during the week. Why is that? Oh, it's still is Dante on? Yeah, it wasn't. Oops. No. Okay, now I've got Dante everywhere. That's gonna help. Okay. So what else do we want? Some people should be sleeping. Hopefully it's calmer now. Airtight. The semicolon is on the home row. There's no excuse. So right now, R type is exactly the same as I type. But we are going to add a twist. twist, which is going to take our sub, which is another R type, and so it's going to take an ident, a colon, and an R type, and pipe, and here I don't know, I don't have a prop, I guess, but I don't have a prop yet. We're going to have to define this. R type to still too many, and we can define prop by p-true prop. Let's write it true. We'll add more propositions later. Interesting. Our type would have in one data constructor. It doesn't. Oh yeah, that doesn't work because there's no prop. Okay. That's rather funny. So what's happening here is that BNFC created an empty data type called R type, and for some reason that I don't know yet. and so then it says, oh, everything I define is easy for GC to handle with EQ, show, etc. And it isn't. Because apparently it's an empty data type, and all these instances, automatic instances, are not. But it shouldn't be empty because it obviously has something going on here. So that should be a constructor, and that should be a constructor. It's R type small letter. Is there one of these? I might have mistyped something. Oh, here it is. Okay. That was a typo. So it needs to be a number that is at least as big as my bigger one, like there. So it's a weird convention that lets me use these numbers to define priorities. But it can be 3, it can be anything bigger than 1. So it could have been 1, that will be enough. So we can okay. So we could print, maybe if I can type. So we could do x colon nat to nat such that true. I think Ray would like to be here to interesting to read all about these R types things. What? This is amazing. Maybe actually it's just I'm using the wrong printer. Let me GACI. Let me open it here. vterm 2. So here the prompt is whole stack GACI. Fine experiment. Oh yeah, I can't write an X. That's true. due to how my experiment, my Emacs is configured. Okay. Okay, so that's what was defined. There's way too many of these, but we can. I can restrict it later. Maybe I should restrict it now. So here it defines the type expr. Well, print is show together with. Let me show you. Just well, it's really here, but that's interestingly slow. Okay, so print is a show function that just prints on the screens, where show just returns a string to me. But then, I guess I should maybe I should not do print and do put strlen. Now I need to. Oops. Did I save? Okay, so that's kind of better, actually. I don't know why it did that, but it decided there was not that. Maybe Unicode works now. Yeah, that's pretty much it. I am very confused. Alexa error? Oh, that's because I didn't save both files. Aha! Indeed. So we can use our Unicode. That's just going to protect us against a lot of collision. We can... Whoa, that's new. Okay, no capital letters. So that. The hard part is always, spooky. I have no idea why the quote it decides that it should print this on several lines. I'll figure some other day. Okay, so now we can start defining functions. Specifically, we can split every. Okay, I don't want to speak about the nice noise of the tea pouring. So we can split refine type into into a intrinsic type and a proposition. So, oops. Or like underlying I type takes an I type, returns an I type. Underlying. So, Capital, you seem to be fairly familiar with Haskell. You studied it at school. It's fairly unusual for French people. So what were we? RNet, arrow, R sub. So RNet maps to INET. Doing your thesis. I didn't know you did a thesis. What was it about? Oops. And where was it? Yeah, okay, yeah. OCaml, of course. I did a lot of OCaml during my thesis myself. Microelectronics. Okay. So tell me about microelectronics in Haskell. I want to know. This is not going to pass. My God, I should. I guess it's R sub. I should program more with this keyboard. Yeah, so I'm curious. Tell me about it. And that's just underlying. Do architectural exploration. Okay. So you were describing electronic boards. Were they digital boards or like analogic boards? Or circuits? Well, also has 3 elements. That is true. Okay. I'm just trying to figure this out. Okay. Monads to express alternative implementations of parts of electronic designs. So you had like a different monad for like circuit bits, or a monadic computation representing a circuit bit. Aha. Oh. Can't do this one yet. I need more stuff. So we're going to punt a bit. Because what we want here is something like for all x constraint t of x implies constraint u of f of x. So first it's not, it's something on term. To that of register transfer level Verilog. Can I ask you where you were studying? That's really interesting. Grenoble. Okay. I've got a colleague that did some could probably understand what you're talking about. He was in Rennes, and also did some Haskell while doing this sort of things. Not quite the same. It was probably more computer sciencey because it was involving polyhedral computation. I was kind of wondering if it was the same place. Yeah, okay. Grenoble is weird. Is that because there's like 7 schools plus the university, and everyone goes to everywhere. I don't understand how it works. Here I want a term. It's not term, it's expert. Woo! And so that is takes empty, and that will take f. I know a couple of people in Grenoble, but they're all at NC Mag, so I don't know if you know them. I'm sort of confused and clicking on things. No, it doesn't ring a bell. I'm sorry. But the fact that things over there, well, anywhere in academia nowadays, is a hodgepodge of different affiliations, is absolutely not surprising to me. So we'll need this for all and this implication. And we'll need substitution, I think. Not for this one. Let's start with for all then. Yeah, so back when I was doing my PhD thesis, an admittedly long number of years ago, it's like 12, 15 years ago, I was, one of my advisor used to say, I refuse to put any affiliation logos on my slides, because if I was starting, I would have like dozens to put, and that's completely nonsensical. So I put like, he put like one for the main affiliation, which was in RIA. But yeah. So now there's a prop. Yeah. I wonder if I wrote my priorities the right way. Yeah, I think it's fine. So there's a prop one for now, and I will take a prop one. And return a prop here. I have so much trouble with priorities in in parsers. I always like misremember what goes where. So it's also a bit like it's a bit implicit here with the parentheses that are added automatically. P for all. It's also prop. So a higher number means tighter, basically, here. So we have a for all, ident, colon, binary type. Colon should be oh yeah, precedence. Yeah. It's the most common name. I just got my names mixed up. R type and a prop. At some point I'll have to decide which is my separator. I need to give it a coercion. I have no idea what this error means, but we are going to ignore it. I forgot that semicolon there. That might have been this. Oh, well, we can't ignore it anymore. Syntax error, add line 21 due to lex error. Oh yeah, thank you. That's line 21. That isn't. But that may be 21 of this, because it doesn't properly... Oops. I've got a call to type in. Ooh. Oh. I see. Yeah. So that's what happens when I type ADS in my editor and not ASD. Well, ASD instead of ADS, sorry. So A means surround with some delimiter, S means single quote, and D then the entire document. And ADS, in that case, D is double quote, and S is the symbol at point. Before prop 2, there's a syntax error. Less confusing than VI. Oh, VI is less confusing than my really weird Emacs mode that four people are using. Maybe. What's really confusing is that, so you can see, if you see the color changing at the bottom of the screen, this is the modality. So I'm using a modal mode. And some of the things like, K is left and L is right. So it's a bit different than the same things for Vim. And it's very, very confusing whenever I do Vim. So there's a syntax before prop 2. Somewhere in that line, really. Or maybe it's here. Oh, it's coercions with an S. Here we go. What a great error message. So of course you can configure your Emacs to be a bit like Vim and have the same symbols and things be less confusing, but I wouldn't do that. That's way too easy and sensible. So now we can do the thing. So this is bad, and it will cause errors later. And we're going to do this, and p-impl. That's a good point. Let's do something. The problem is we'll already need some sort of... I don't want to do De Bruyne, but it's already annoying. Yay, I can't move. So I want app, I think. And here I want varx. Does that parse? It applies to too few arguments. That sounds implausible. Oh, there's a type missing. Ooh. Ooh. Okay. So I'll need a way to generate new names. And there's something wrong about this, is that I don't get warnings because it's too eager to send me to tests. Can I ask it? Can I... gonna check a few things. No. Okay, so it should stop for warnings. Like, I don't know. But it doesn't. Can I specify not to? Oh, maybe it's because I use run instead of... Let me try something. Test main. It doesn't know what it's supposed to do. Maybe it does the opposite. No. I'm very, very sad. Looks like I can remove this to get my warnings. Oh, there's no warning. Ouch. So maybe... What does my cabal say? Oops. Nope, not that one. I don't care about this. I don't know why I still have it. This one? Oh, I see. That's what I need. Whoa. Refine will have an define but not use f, where okay. I don't want one on this file, I guess. No one name shadowing. Define but not used. Unused matches. Doesn't produce very high quality code, I guess, but it's produced code, so it doesn't matter. Of course, it's a different warning. Normally, there's the number of in a normal terminal window. I would know how many incomplete patterns. What? That sounds bad. How many of there are these? Oh, good. And there's one in main. That's the one I wanted. Okay, we're back in business. I'm going to make a small whip commit, just cause. Okay, so indeed something is missing because we don't do rsub, but for rsub we need an extra function. It's just substitution function. Oops. Substrop ident expr. I can see the generated code. You can like pass minus dump slice to and maybe even dump quasi quotes to GHC, and that puts everything in a file. And I can't be bothered right now. Really. Right now, I won't be able to. The substitution will be very trivial, but we will still do the so p true. It's not a very highly maintained library, and I guess it's just like it's not. You're not supposed to look at the code all that much, but yeah, I'm sure it's fine. What could possibly go wrong and all that? Edge prop. So impl. So you substitute both. No. Q. Oh yeah. Okay. Interesting. So now it's still incomplete. I need to do for all, xt for all y term. I'm gonna type. I'm gonna terms. That's confusing. Can I do to and will it not complain too much? And here I have a proposition P, and I'm going to do something very, very wrong and do for all y to subprop xt p. Okay. Okay, my typing is fantastic. Okay. Yes, I mean P for all. And now I think I can do the last one. So R sub, which is an ident, a type, which I've also called T, sure, and a prop. And here they can, and so my term, let's call it E this time because I'm very, very consistent. And the constraint is constraint T et. It needs to be of type T, and I will need an end, which I haven't defined yet, and subprop xtp, and pn doesn't exist, which is fine. We're going to define it. Nope, that's the wrong one. Okay, what's wrong? Right. Oops. Yeah, that would be E. Indeed, now I need to add. Types are so wonderful. Just follow the types and okay. But now we can do something a bit better. We can define that's not very nice. T equals okay. We can print T, but we can also print tree underlying I type of T and puts through learn print tree of constraint of t and of var, let's call it f. Which I can actually do by expr f. And there's something, I don't know how I managed to do that. That's one mad transposition. Woo-hoo. Okay. It's almost satisfying enough to stop here. I'm gonna add some entry points to the other thing because too many things will be exported very soon. I think. Well, it's actually all right. No, it's actually all right. Now we kind of want to define a program. And then we're going to add equality to things, and we'll get started a bit and do some type checking and things. Now, we want to define a program, and a program will be a sequence of definitions and axioms for now. I'd just say that. And definitions are basically axioms as well at this point. So def is a program, and it's given, and I'm gonna have terrible conflicts, I'm sure. Keyword def. So by the way, this BNF thing, it also is able so maybe it doesn't work when I do the inline one, but BNFC, the tool, is capable of outputting what's the name? A pigment file to be used for syntax highlighting in LaTeX. And actually, it also outputs a LaTeX description of the grammar. It's pretty nifty as well. It's going to save us a ton of time. All these things that I haven't had to do yet. I still don't know why this is happening, but many of the authors of this thing are like, people I can even find on the phone if I need to. So I'm going to get to the bottom of this eventually. So a definition is just you define an identifier and you give it a type, and that will be it for now. An R type. Okay. And we're going to replace some of these things soon. And an axiom as a program, I'm going to write an axiom in full. Prof. Is given by ax and a prop. And if that doesn't give me terrible conflicts, I'll be very surprised. Well, I guess ax and def are fairly well understood now. Oh, yeah, actually, I know why it's not a problem yet. It's because it's supposed to be followed. Okay, now what's the best way to write a list of these separated by nothing? So I start using that. Oh yeah, it's not on stackage. It's all fine. I remember that there's a link to the doc here. Here we go. That is small. That is better. And we're on read the doc. LBNF pragmas, macros, layout, syntax. No. Left recursive lists. Oh yeah, there's something about lists. Okay, that doesn't matter. But let's look for lists. Okay, that's around here. Sorry, it's still small. Small for me too. Here we go. So we're going to say that this is a decal and this is a decal. But now we want to have a list of these. How do I use this? Maybe I can't use this because well, I need to give it a name, I guess. So I can do something like this. Decal. Let's see how it works. Decal, colon, decal, decal. It didn't yell at me yet. And now I can define a prog. Wow. I was absolutely expecting shit. They're going to start writing a program. We can start doing something like I wonder how we will print it. Print tree. I think you can give metadata just for printing. Prog. I need to. I absolutely know how to use my computer. I'd very much like to be there. Def. We'll call it plus colon nat. Ooh. A natural number. Ooh. Okay, sure. Plus, we can do times Whoa. We can do div, and div is different because the second argument is a natural number, which must be different from 0, which right now is not expressible. So, oops. Okay, now we have some errors. Let's see how it goes. Syntax errors on line 4. Is that line 2 then? 2, 3, 4? Oh, I see. Yeah. Yeah. This is maximally tight. Yeah, it doesn't know how to. Can I ask it to? Let's have a bit of a look in the documentation and see if present levels type correct. I mean, pragmas. Internal is something that is not edited. Oh yeah, internal is something that doesn't have a rule, but that's fine. Entry point is something. No, so no, it's there's a macro. Yada yada. Versions is what we were looking at earlier. Rules, but I don't care. Layout, certainly not interested. Profile, optimization. I don't know how to ask my very nice system to put some \n into things. First example of an LB and F grammar. Polymorphic list, presence levels, semantic dummies. Yeah, that's not it. Okay. It's lacking documentation a bit. Well, we'll keep it at this for now. It's certainly interesting a way to render this. Well, yeah, I'll have a look at the generated code and more intricacies in the coming days. Today is not the time. Today is the time to pour more tea into this sad, empty cup. Now we're going to add something to our program. Because I can't know where I'm going with this. I'm going to add an axiom here, which that will be hilarious. The axiom is for all n of type net for all p of type net. Some syntactic simplification would be nice. For all Let's we have m dot m n dot m times m also times and m equals p. I can't write it yet. That's what I want to write, but implies n equal p divided by m divided. So divided is div right now. I don't have syntax. Div pm. And this is only true if m is different from 0. N equals 0, m. Otherwise, it doesn't even make sense to write this. Right now, I can't do this because I can't pass equality. So let's add and negation. So let's add these. I think negation should bind tighter than this, so we'll add a prop 2. And p naught prop 1 colon equal slash neg. No. Of prop 1, I think is fine. Well, it certainly didn't break everything, but that's nice. Times need an S. Yeah. It does. And what is it? Equality. Equality is an atom. So it will be P equals prop 2. And that will be expr equals expr. Pattern matches are non-exhaustive, as they shouldn't be. 42. X T P naught Q P, let's say, is P naught of 6 prop XTP. Okay, now P equals. I'm going to put it here because it's important. I'm going to need subs term instead now. Or subs expr xt u p equals v equal subst equals xtu, no, subst equals subst expr xtu p equals subst expr xtv. Now I need to define subst expr. Ident expr xt and something. So we'll start with var y such that oops, such that y equals x equal that would be t. Otherwise, it's var y, so I could give it a name. It's u. xt. What is there now? What's next? Okay. Not. Then go you. Yeah, I don't need these. Oops. And finally, app. Subst expr xt u app v equals subst expr xtu app subst expr xtv, and that was supposed to go there. Oops. Very good. And now we can print this fantastic axiom here. And now we will need an interpretation function for this. So we need to do some type checking. Okay. So I will need a map. Yeah. So cabal. That's some containers. This is redundant, but I don't care. I'm going to use it soon. Very soon. And actually, I'm going to do something more. I'm going to do data map strict. I'm going to do an import unqualified. It's just mapping it. Okay. So, type check. Intrinsic. Expr. We'll take. So. An environment is a map from items to an I environment from items to I types, and so it uses an IEnv. It takes an expr. What exactly do I want? Takes a type and returns a boolean, and I also want infer type infer intrinsic expr also takes an env an expr and returns a type. Which is a tad overkill for simple types, but anyway, whatever. It won't make huge difference now because we don't have a lambda. Type infer intrinsic expr and so I've got I didn't write the same. There's an extra s here. Where was I? I need a var x equals map.lookup. Okay, it returns a maybe type. And we're not going to do interesting error messages today. I'll look up x in the environment. Is that the right order of arguments? Yeah. That is true. That's I type. That looks good. Okay, so that's that. Infer intrinsic expr and nat. We don't care about the actual natural number, and in that case, it is just I don't really need to do, I guess. I'll clean that up later. It's already like pretty ugly anyway. So that would be just I type so just I guess just this or return this, whatever. Type infer intrinsic expr env f app u equal do. This one we're going to use that quite a bit. So we're going to infer of f, and we're going to assume that it has a narrow type. Otherwise, that will automatically return nothing. So we're going to do I arrow and I need too many conventions. U T and And then we're going to type check guard type check intrinsic expr, the same environment. We want E with type U, and if it does type check, then we return T. Fantastic. In this case, this is very easy because there's only type checkable thing, type inferable thing, sorry. So we take the environment, the expression E, the type U, and we return type check intrinsic, no, not type check, type infer intrinsic expr and EU equal just U. Oh, not U here, sorry. And I and E, sorry, equals just U. Guard is not here because it's somewhere in control monad. Couldn't explain. Defined but not used env. 69. Okay. I've been wondering for a while if I should put some music while I'm coding, just to make the ambience a bit less me thinking with my screen. I know what your opinion is. I don't know. And I actually I need to figure out what I'm allowed to stream as far as music goes. I have a tool somewhere that can stream music from YouTube, but I'm not sure it's only things that are legal. And I don't want no trouble, sir. So, intrinsic typing is there. And what's sort of important about this is that we can just assume that so if I assume that something is well intrinsically typed, then I can make a ton of assumptions for the type checking of non-intrinsic type thingies. So you can immediately do the comp arrow. So we can. This assumes that so what's called underlying I type of T equals IRO something something. I should write it this way. Yeah, of course, type errors. So it assumes that we have this type here. This type is an arrow. And so it will take an R type and it will return a pair of R type, which is, and a prop, which is a possible constraint that you need to get there. So we can do comp arrow, and it's also where the magic is beginning. It's 11:30 in the night, and we're starting to barely touch what I want to get to with this. Next time, maybe we'll do some interesting stuff. But for now, let's just try to have a time-checking algorithm. That would be very neat. Also, PSA, if you're in chat, you're absolutely welcome to say hello. I'm friendly and approachable, I hope. So, what are our choices? We can be an actual... Oh, well, that was well timed. Hello, Droplet 739. It's Bavik. I'm super happy to have you here, actually. How are you doing? I've been thinking about the what's the name? The batch type quite a lot. Well, I'm fine. We're making progress. Someone has joined this week, and who will be taking over the linear base work from you. How is the thesis going? I need to show you something. You noticed a new commit. Oh yeah. You still follow the repository? That's cool. No, well, I don't need to go that far. I'm lost. LensEF. Source control tactic. Look at this friend. Lots of reading. I guess at this point of the thesis, it makes sense. It's relevant for tactics. I've understood this. I've understood this type quite a bit more now. And it's just basically a fancy list that has absolutely terrible performances. So you probably get way better performance by doing partial functions and splitting a list in two. But I think there's even better ways to go. So I want to investigate that at some point. But it's exactly for the same sort of reasons. Like I defined tactics as some kind of traversals. So tactics is like Milner tactics if you know what they are. And that will be useful in that proof assistant I'm trying to write right now, but not today. And for some things, you need to sort of cut off the tactics at some point, refi the traversal, try to see if there are errors or not, and change there. I think it happens here. Yeah, you do a run batch. So you use the batch function to sort of stop the thing, refies it into a data type that is actually closer. So you just split the data type that that Milner would have in two parts, like the chaining part and the actual refining part. Anyway, see? And so having worked on that with you helped me a lot when that problem arose. So that's cool. Yeah, I was very happy about that. It's better when like things sort of mesh because you get to do more things. So one choice is that we have an R arrow here. T, let's say. In which case we return a U, a T, and top, which I guess, is easily written p-throw. Another possibility is that we have sub. Oh, it's not quite prop, is it? Is it a function from term to prop, probably? Let's roll with it for a second. L sub x a type and a prop. So you first get like VT Q bang pattern to make sure that errors are propagated, I guess. Because it has a precondition, let's do something as well. So that's something I've been doing a lot. I don't remember where this comes from, so I will have errors. It will complain. But whenever you write a function in Haskell, that is partial, in that it has a precondition that needs to be achieved, and that the proof is the onus of the proof is on the programmer and not the type checker. Then I would like to add a Haskell stack constraint to make sure that if someone mistakenly uses the function where it doesn't work, they get a more useful error. And I think it served me quite well, so I'm going to continue using this. So that's with the comp arrow, the U, we get this in, and that's where something needs to happen. I don't like how it aligns things. In so return the same V, the same T, and want to return Q and P. But obviously these P end, this will not be correct. Okay. Can I? Oops. Okay. Okay, Haskell stack comes from somewhere. Is it with what? Okay. GAC.stack. Is there a better place? Well, let's do GAC.stack. I don't know. So one of the things that I dislike a lot about Haskell is that if you don't take a lot of effort, if you don't make a lot of effort, sorry, then, oops, then you never really know what module should be imported, what's intended. If something is defined in several modules and Haddock can see that, it will like choose a random module, usually the worst possible one, to display as the default. You can put some not home and internal pragmas on modules to avoid this. Okay. So this is incorrect because I'm completely ignoring the X here. I don't want to. So let's you know, if it's not term, it's expr. So we can do lambda y, lambda, it's a term, so lambda e, q of e, and subst prop x ep. And that is just or something. Who cares? And then there's the other cases, but I know they can't happen, so I can just do error. This has to be an arrow. Let's do. Well, actually, we don't need that because it will be in the backtrace because of the Haskell stack. So, okay, here we go. And so that's sort of where this refinement type thing will come into place, because we can do a type checking and a completely deterministic type checking that will answer yes, no, unambiguously first, and will give us that the terms have at least make sense. There's a function where you need a function, and if you apply something, it has to be a function, etc. And if it's a natural number, it will be a natural number. And then you apply the refinement on top of this. I'm got some hiccup coming up. Anyway, so and so on with a type of this sort, we can start doing some type checking, I think. And I probably got it wrong, so we'll try again. So, yeah. Let's look at what it looks like. Type check, refinement type, refinement expert. I'm type checking an expert. I want an R type and a return bool. And I don't think I want an infer thing. It will only be for variables. We'll see. I'm not sure what I'm doing here. So it can be and it can be a var x, and so that would be a type t. And well, we don't want to return a bool, really. We want to return a bunch of constraints. So constraints, and maybe you can turn that into monad later to type constraints. There's a list of prop, I think. So it's maybe we don't define this and just use list of prop. So I don't want an IEnv, I want an REnv though. So type REnv map ident R type. What have I done? Okay, and this assumes that that, like, type infer intrinsic expr of E equals just something. We just like assume that is true. So var x, we have two things, and we just have to check that the constraint of x entails t, I guess. Actually, we have a bit of extra data. This will be nice to package into a nice monad later. So this This extra proposition here is the givens. It's what I already know. So I may want to type check something under the hypothesis that some proposition hold. So the list is really a conjunction. In both cases, the list is a conjunction, but it might be better to treat it as a list. I don't know yet. Actually, I'm pretty sure that at least this one I want to treat as a list. And maybe I can sort of eventually name these or something. I don't know exactly. So I get, I can look up. I'm gonna assume it's in, and there will be an error if not. So this can also panic in various ways. There's assume written on it. So we started by doing x map.bang. Oh no, sorry, it's the map first. Env map.bang x. So that is let's I don't know exactly what I need to do. Actually, I do something already. Goal equal so that's really a list of goals here. So given of x equals constraint type of x. So that's the thing we know about x based on its type. So we've basically decomposed this type into like something plus a given, a thingy that does stuff. It's a subtype of something in a way, and I just extract the subtypiness of it. And today we have quotients. I might have to extract the equality relation on it. I'm not sure yet. But quotients should be easy. Oh yeah, I should write that it's the intended language is at the horizon is inspired by the internal language of toposes. Here we go. Which reminds me that I should probably just check up all this a bit. Something is happening. Okay. So where was I? Oh yeah. So now we know the constraint, and what we want to do is to say we return one goal, which is made of given of x colon given, and I need with all that I need to prove t, no, not t, I need to prove constraint t. Okay. Oh yeah, because given of x is that applied to var x again. Trade in t. Okay, let's do e oops, e. Fantastic. Okay, I think that's correct. I don't know if that's correct. I think that's correct. We have natural numbers. I don't need this natural number, so it will be. It's just that it is a natural number is what I want to know. T equals. Actually, suppose more than this. Suppose that is just of underlying. What's the name? I type of t. That matters a lot. So we know that t is something that has integers in it, like it's a sub of integer eventually. And so we also have a single thing to prove, which is that the given prove that constraint te and finally we have app, and that is hard. So let's think about it slowly. So we know that f is an I-type, so we can assume this. And we don't know anything the real question is, do I want to do the bidirectional thing again? Do I want to find stuff about f? Well, if f is a variable, I'm only allowed to apply it to e if e has the appropriate thingy. So intuitively, I do want to do some inference thing. And so maybe all these reasoning will be turned around. But while I do inference, I may have to. Okay. So. At the very least, I will have to do no, type infer okay. It's complaining because of writer, which is somewhere. Sort of disheartening that there's not a monad writer thing. Bell. Transformers. Oh, there's one in MTL maybe. Writers are terrible, but that will be fair enough for me. So anyway. Excellent. MTL. Ooh, found a hole, as it should. Several holes, actually. So now we can sort of equal. So here we can. Am I returning an R type? I think I'm maybe returning an R type and a constraint. I'm not sure. Maybe just an R type. So let's have a look at this. In which case it's simply return and bang x. Let's just comment this out just to see whatever is happening here, because we can also infer nat which is our nat. And we want to infer type, and type is also inferable. Oh yeah. Type infer. You kind of see that this is the meat of the problem because I don't know what I'm doing. Given f at e so type of f is type of f, sorry, type infer refinement expr in the same and with the same given of f. Yeah. Okay. And now we want to define let type of arg, type of return, and constraint. And constraint, like, well, given of f, because that's what we inferred is the type of f. So we already know f has that type. Equals the comp arrow of type of f. Okay. So that's the source of the call stack thing for the records. And now we want to type check refinement expr env given. We don't really add anything to the given in this form yet, ever. E, I think, yes. And the type is the type of arg. And finally, we return f, the type of return. Okay, so it's mostly the same algorithm, just with slightly different constraint. So that means that we've covered all the types here, I think. Let me, right. Except we want that to be a writer goal unit. And this is a very different expr so the env given e. So just as before, there's just one case because we don't have a lambda. Lambda would need to be checked. U we'll call it t, yeah, equals. So we equals do. We'll first infer the type of e. So type of e is type infer refinement expr of on given e. Then we can get the given of e, sorry, as this, except that's e. Now we know that e verifies this, and then we can not return, we can put, I think, is the name of the function in writer. I'm not sure. We're going to click this just to figure this out. The goal given of e given and constraint. I think my click was very inefficient. Constraint te may not be put. Hello. Load something. This is slow. Isn't my stream going well? Seems to be going well. Okay. Oh, here we go. Click button. Wait for a bit. Maybe it's just slow because my stream is taking all my bandwidth. It's tell. Interesting. There's evidently a typo. So a good solution is to just not try to find it and just copy paste things. Oh. What? 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 Sorry, what? But to what? Type check? Oh, it's type check refinement, that is. Oh, I was looking somewhere else. Okay, yeah. Okay. That makes a lot more sense. I had two typos, not one. I thought it was the same one. Defined but not used. Here, okay, so we don't need it. And here, you don't need it. Ah, that's cool. Really? Ah. Oh. A, ooh, ah, ooh, e. Ooh. Should I actually accumulate the given as well? Because I may have to use it. So actually, it's sort of something that I want to know, right? So I should accumulate them in a state-like fashion, I suppose. This is actually a bug. So I'm just trying to figure out what I'm supposed to do with this. So I know something about f, and I need to remember it because it is not part of what I'm doing then. It might matter later. It doesn't matter for e all that much, though I might as well give it there, but mostly I want it to be remembered. So I kind of type TCM of A equals writer goal. TCM equals writer goal, I guess. Oops. And so we could just TCM it just calls for more T. Ugh. Okay. So I'm going to remove tell and do emit. Takes a goal and returns a TCM of unit, and emit is currently tell of G. And so here I can do emit and actually we can do Yeah, okay. We'll improve on this in a second. We can. So I think that we want to do is to add a state t of list prop of writer goal. And I don't have state t because it's somewhere else. And that's probably import control.monad.state. Fantastic. We're going to change this to be do. What is it again? Get, I think. Given is get. So instead of emitting a goal, we emit a prop. And I'm a bit worried about this. I'll clean it up. It's not the right monad. That's fine. I may just like use capability to put some order into this. Emit and oops. My fingers. And here we can assume given of f. Of f. Neat. A bit too neat, if you ask me. The risk is that assume is not scoped properly. So there might be some locality issues to let's push this. It's nice and sweet. So the repo and the branch, if we want to play with it, is here. Yeah. This is yet another detour I'm taking on the way of a project where I wrote I'm going to take a lot of detours. Personal projects do that. I got nerd sniped like 3 or 4 times in the past year or so in the way of this. So yeah. So my guess is that we need to make sure right now there's not a lot of scoping issues because I'm only doing terms, but it will show up in a second, I'm sure. Because I'm just assuming P, but P only makes sense within a context. So I might have to sort of reorder this a bit so that there is some locality involved. I could use some continuation monad or something. I'm not exactly sure how I want to do this, and then just I don't exactly know what I want to do with this. Or restore things after I get into scope. Or for now, I'm just gonna do random wrong things. It would be nice if the code could stay this one because it looks good. But I'm not sure how to say that some things are not allowed to escape scope somehow, or that I need to abstract over constraints, or I don't know. GHC does that somehow, so it's probably doable. So Yeah. So now we can what we would like to do, I guess, is type checking a proposition. Um, um, having name labels is going to be a pain soon. But I don't want to define every type twice. I don't know. Type check proposition. I'm thinking something right now is that in the syntax of equality, I don't specify a type. But equality is per type, definitely, if I want to be able to do quotients later. And this can be problematic. So maybe I need to specify a type for each of these. Right now, I'm just gonna assume that I can do something for equality, but if I don't specify a type, the problem with this is that if I have two refinements, it might not have the same equality. So it's not sufficient to infer the unique representational type, though it's sort of necessary. Yeah. And so if I only know the refinement type, then I don't have fully a definition of equality there. Not the refinement, like the intrinsic type, sorry. But then the term is allowed to have several. Like if I use M, it has several intrinsic types, so I can't really infer the type there, like in a unique way. It's going to be annoying, but this should not be partial. Prop. This type is a lie. Type check proposition should fail gracefully if the intrinsic type is. I can't type this word. I don't know why. It's faulty somewhere. Given, and that's my proposition. So first example is true, and true just is nice and all. Oh. Quit. Okay. There's a bit stuck. Okay. I'm absolutely going to do equals last. So I don't need these. P naught of a proposition is simply do type check proposition and given P. Env given p end pq equal do like this. A more interesting thing. Actually, I may want to. I don't know. So do. This is not the only thing I will do. I can emit. No, I can assume P for the type checking of Q. Type check proposition and given P for all X of type T and P with X in it. So I have to a good question. So here again, this should probably very much be scoped over Q, really. Here we want to extend. How does the map work again? Yeah. Map lazy, is that insert? It's map.insert, I think. Insertion, map.insert, or insert with key. So insert, oh sure. Insert, the key would be X. We would also do T in env given P. So that is properly scoped. And this is fine from the capture point of view, so I don't have that problem. And now everything will be wrong. P equal z. So E kind of like U and V for this, but everything sort of is named the same. Will do. So I think what we can do now is we can infer the type of view and check that the type of V is the same. Just assume that the type of view is the type of the equality. That's very asymmetric and overall. So I'm going to write that it's very asymmetric and overall. Also, I can't write asymmetric differently. How does it spell two M's, I guess? Yes. And we're going to do T type of view is type infer refinement expert u and given u, and I just need to type check. Also, we need to type check to. We'll do the intrinsic thing as well. Nice. It's very funny. Okay. So now to avoid errors, we're going to do I type of view is, and this one is, no, this one is fine. So I need to put I type of view is type infer intrinsic expert. Oh, that's okay. Map.map. Underlying I type env. Yay for laziness, I guess. U. And this is completely fine because there's a single one of them. So the I type of U needs to be exactly the I type of but that's a let, right? It just returns type infer. Yeah, it's a maybe. Okay. It needs to return something. So it's going to panic if I'm sure just here. And this is let's just okay. Let and then we can just do equals case of type check intrinsic expert I onv t I type view of true false. I need to make sure that this is bang pattern. But again, this needs to be non-scope because it's still called V. Okay. Now we can like type check a program. So type check program. Takes an env a prog, I think. Prog, yeah. And returns a TCM of unit. Type check program. Env prog of decals equals go env decals where go env decals equals equal return unit and go env definition. So that defines an ident f at type t, and then it's followed by more decals, in which case we simply type check. We should go actually in map.insert ftenv in decals and go env axiom, which is a prop colon decals. We type check proposition and p, and then we go and that's okay. Go env decals. Woo! Don't do this. That's not good. Oh. Fair. Fantastic. Now we're going to let prog equals in printy dot call example. Interesting. Print tree example and put yeah, I'm not quite done yet. I need to define a run TCM and a couple of print functions. So I need to, well, basically I need to deriving show and I need to run for TCM. And this run takes a TCM of unit and returns, you know, the list of goals. And so run TCM of act equal. So I think there's exec state, but I can like ignore everything. first need to sort of remove the state. Oh yeah, so exec state T I need, I guess. Okay, root doesn't exist. Fantastic, that's exactly what I need. No, it's not exactly what I need, because it returns the S, and I'd like it to return the A, but I can sort of ignore it anyway. There may be a better one, but say T of act. And then there's one for writer, I guess. So there's this one, and I'm sure there's a exec writer. Empty at the beginning. Yeah. So now should be able to put through line or to print, I guess, $. So run TCM apply to type check program applied to map.empty and prog example. Okay, I need a better printing function. So instead of this, we're going to show is not the right name. I could just do a print thingy as well, but I don't know what the function is for that. So I'm going to where show show of goal so hips concal equal so like so map print 3 hips. What is interspears? Never remember that function. That's not the one, I think. But that's there's one on the side. Intercalate, exactly. So intercalate like this in this, and then I finally add I don't know what I'm supposed to type. Oh, here it is. No? Here we go. I was confused for a second. Print 3 concal. Intercalate is in data list. Okay, so there's plenty of trivial things, but one of them I should have to prove that it's because okay okay so I don't want to print the list like this. It's pretty unreadable. So for now, I'm gonna just use space here. That's not gonna be very readable either, but it's probably more readable. Okay. So I've got to prove true in many circumstances. So maybe we can clean these up, but I want to see if there's one about M needed to be. This is always a given. I think my algorithm is wrong. So we're going to do a special case, like case like no, actually no. Just emit p true equal return unit, just for the simplification. And this one is true and true. Fantastic. Okay. Okay, so something's wrong. This is not what we expected, because we have this axiom that needs to be type check, and this is supposed to require that M is non-zero. Oh no, it's supposed to. Oh, that's my fault. Okay. Here we go. It's also trivially solved by this, which I get because of this. Boom, 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 boom. Oh yeah, that is very satisfying. Okay. Well, I submit that it is a good time to make a break. So I suggest that we stop here on a somewhat victory thingy. I think this trues will happen a lot, so I can also assume true doesn't help either. So we can sort of simplify all of these. I'll have to have a better printing for a list of goals. Which we can do. So yeah. So that is sort of the idea. Eventually, I want to be able to define plus and type check something, and prove things about functions. But that's sort of secondary. We could axiomatize everything. So we could have successor and have some proofs like plus and having recursion, etc., etc. I don't have that yet, but we could axiomatize a lot of things rather than proving them. The choice is completely ours in this design. Of course, because adding axioms all the time is very error prone. Having some internal logic is quite good. And so being able to define terms with lambdas and case and so on and so forth. And so having even like inductive types or stuff like that, I don't exactly know yet. But the point is that you're writing things like this, and just to be able to assume this, you still have to prove that. So right now I'm just like collecting everything and putting them at the end, but so the goal will be to have some syntax here to do some proving, and just okay, somehow just giving the proof obligations, the side conditions that are needed to even express this property. And there will be some sort of, triviality solving to avoid having to prove everything as things go. But we have done our first step, which is just like transform a type checking algorithm into a there are some implicit assumption there sort of thing, and let the programmer prove them. And when we know how to do this, we'll also be able to just add some proofs and refer to proofs. But then I have to do a whole tactic language, and so it will take a bit of a while. Well, it's probably another stream like this, maybe next one. I'm not exactly sure. I want to schedule my time, but yeah. So I think let's just this is pushed onto the repo. Code can be checked. And yeah, so this is all milestone. We emit constraints, and I'm going to stop there. For the program, next time I'm going to do some video games next week, almost certainly, and I'll be back in 2 weeks on this very program. So that's all for me tonight. Good night, everybody. Good morning if it's morning where you are. I'm going to cut stream now, and until next time, stay curious.